Hi there, everybody, and welcome back to another episode of Building Science Digest. I'm your host, Christian Kennedy, and today we have Dennis Michaud, the Managing Director of Offsite Solutions for CertainTeed with us today. Dennis, welcome to the podcast.
Christian, thanks for having me.
It is great to have you here. We are going to talk about literally all things offsite construction and the driving forces behind that, and you are the man for the job.
Excellent. Let's get into it.
Let's get right into it indeed. At the highest level, what is offsite construction and why has CertainTeed gotten behind it at this point in the industry's life?
Yeah. Well, really at its fundamental level, offsite construction is building part of a building in a factory.
Right.
And the reason why we're interested in offsite construction is there's a lot of confusion and difficulty around executing building science, good building science on the job site. We all know it's important to keep the occupants comfortable. We know it's important to manage moisture so there isn't, conditions that could create mold or could create, poor air quality, anything that could damage the building over time. But knowing exactly what to do and what each layer is needed to get that done is very confusing. And so we wanted to make good building science easier for our customers.
Interesting. And so we're able to do that, or you're able to do that because, I guess it's really in the word itself, because it's off site, right? Like the work that's being done is not happening on the actual job site. It's happening off site. Is that the sole driving force behind CertainTeed getting, again, behind this?
I think there are other really important reasons why offsite will continue to be more and more important in the North American construction industry. So one is related to labor challenges. We know that there's a big lack of the necessary skilled labor to build all the homes that we need for people. And unfortunately, the problem isn't getting any better. So what we need to do is change the way we build, just a little bit in order to be able to build faster at the same high level of quality, and also make it easier for the folks on the job site to get the job done, to execute good building science.
Interesting. Okay, so it's all equal parts in an effort to benefit the community as a whole, right? And the users, the homeowners, whatever the case may be. You touched on that labor shortage. You touched on the disaster recovery. What other factors are playing a role in possibly the increase in offsite construction?
Yeah, well, actually, I didn't mention disaster recovery, so I'm glad
Did
you
I
did.
not? Oh, goodness.
Yeah, so I think that's a really important point, and it's unfortunate reality that we are seeing more and more natural disasters, and obviously that's an incredibly traumatic situation for a homeowner, for a community, and for the overall economy. So we looked at this and we said, we can talk about the problem all day, or we can do something to solve it. So one way to address it is, how do we help people rebuild faster? And let's not stop there. Let's help them rebuild actually not only faster, but better. How do we ensure that the next time there is a disaster, that their house is the one that's left standing, that their house, their family is safe, and then they can go right back home, go to bed the next day, and wait out the next storm.
Feel confident.
Yeah,
right, exactly. About the structure they're in. It's good. So I teed you up for that one. So what are some other factors, right? And we touched on labor shortage. Now we touched on disaster recovery. But what other ones out there are playing a role similar to the ones you just mentioned, if any?
Yeah, I think this is a little bit related to the disaster recovery topic, but it's also speed. Right now, to build a house, depending on where you are in the country, it can be more than 12 months. Right. So for a lot of people, that's just too long. It's not great for the homeowners. It's also not great for the builders, right? Because they know that there's this huge demand out there. How do they meet the demand if it takes months and months to build a home? So what we've been able to do is compress that basically in half. So it allows builders to build much more per year. It makes them more profitable, and it also puts more families in homes.
Interesting. And you mentioned that I was doing some research before, but I saw, was it like 20 to 30% more efficient in the time spent building, obviously offsite compared to a traditional job site? I think is one of the numbers I saw, but it's a massive difference when you say 12 months, right? We're talking about 30% of that could be a quarter, if you will, right? And that is a big difference in a builder's, right, portfolio and the number of jobs that they can complete. What is the process to take the construction, the finished product, and move it to the actual job site, right? Because we're so focused on the controlled environment and being able to do it more effectively and more efficiently inside. But what is that process to take the finished product now outside?
hmm hmm Well, and I want to get back to how we get to the finished product. But,
Sure.
in terms of, so the let's say the offsite panels, we call it one precision assemblies, are manufactured in the factory. Now they need to get to the job site and get installed. So we deliver them to the job site. It takes a day. It's usually, a few trucks. These are the same trucks that are delivering, any other building material. Same trucks that deliver lumber, roofing, siding. So in this case, all of that is coming on a truck as a panel. It's delivered to the job site. There's a crane already waiting there.
Right.
In our case, the cranes are a little bit smaller than the typical cranes you might see in, for example, modular construction, but it's the same basic idea. The cranes are taking bundles of panels off the truck and they're putting them on the property in a staging area. During that time, these panels are completely protected from the elements. They're actually wrapped in essentially boat wrap. So the same thing that
Oh, wow.
protect your boat from in the winter, from snow and whatnot. We use that same kind of vacuum sealed
Interesting.
package.
I didn't know that.
So they open up the bundle, and the bundles are organized such that the first panel they need is on the top and the last panel they need is on the bottom. Of course, they're all labeled and they have an instruction manual very similar to, putting together your favorite furniture.
I was just going to say,
think it's a little easier. Yeah. So the crane comes and grabs each panel. The panels already have these attachments waiting for the crane. It puts the panel onto the foundation. Let's say if it's the first panel, a floor panel goes onto the foundation. If it's a slab, it doesn't have floor panels. If it's a basement, it would have floor panels.
Gotcha.
And then one by one, the panels are put onto the basement. And the bolt holes are already there. They just bolt them together.
Wow.
They're using a lot of the same fasteners that are already used in construction. So one thing that was very important.
So nothing that's net new.
Yeah, we're not trying to make this such that the end result looks or acts any differently than a normal, very high performing home.
Sure.
Yeah.
Interesting.
So it takes depending on the size of the house, it can be as fast as a day. I think that's more on the extreme, but we've done it.
Yeah.
Or, 1 to 2 weeks for a very large home, 5,000 square feet. It might be 2 to 3 weeks.
Right. Which is different than the 12 months that it might take, or you alluded to earlier.
Yeah.
Right?
And then at the end of that, you have a fully dried in home. So it can rain, snow, wind, do whatever. It's insulated. So you can put space heaters inside, and it's not going to take a lot of space heaters because these are very well insulated.
Right.
And all of the work from then on happens on the inside of
the home. Wow.
So that means not only it's happening faster, but if you're up here and, we're in Pennsylvania, it does snow, it gets cold.
Right.
All of the work that the trades are doing on site is happening in the warm indoors.
Right. Yeah. So you're not reliant on the weather to be perfect to move forward, right? The outside of the project is already complete.
Yeah.
So you just move into the inside. It's so fascinating. I didn't know about the boat wrap and the stacking and the ordering. Of course, why would we not do it that way? Yeah. You mentioned modular, and there's a distinct difference between modular and panelized, offsite. There's a lot of different words that are out there. Can you, educate me on the differences, right? And just start from the top, and we can kind of work our way down.
Yeah, sure. So, and it is true, Christian, there's a lot of confusion around the different words.
So I'm not alone.
You're not alone. Okay. We even get confused sometimes. But really, I would say that there's, two different categories and two different kind of regulatory or code environments. So let's start with the second one, the code environment.
Sure.
So there's offsite construction that's built to the same building code as any other house that was built on a job site. That's the kind that we do.
Okay. Got it.
So at the end of the day, it's completely compliant with local building codes. So if you're building in, In Maine, there's one building code. If you're building in Florida, there's a whole other building code. High wind, another building code. So
And you're able to build to each state's specific building code.
exactly, the state, in some case, the city, depending on
Sure. Oh, right. Yeah.
the specificity in the state.
Huh.
So that's one. So there's other types of offsite construction that follow a different building code. It's called the HUD code.
Okay.
That has advantages and disadvantages, but for us, it was very important that the end result is just like any other, well-built house.
Okay.
Yeah. And then the other difference is between panelized and modular, or 2D offsite or 3D offsite. Those are two words for the same thing.
Okay. Yeah.
So in modular or 3D offsite, you're shipping full spaces from the factory to the job site. So these, they look like a 6-sided box. They're typically 40 to 60 feet long by 8.5 to 16 feet wide and, 9 feet high.
Wow.
These are big honking boxes. The advantage of that is you're doing a lot of work in the factory, all of the interior finishes, the plumbing, the electrical, the plumbing fixtures.
Oh, so all of that is also being done in that controlled environment
For modular.
For modulars. Yeah. The electric, I hadn't thought about that yet. Okay. Interesting. Yeah.
So the other type of offsite construction is panelized, 2D offsite construction.
I like that 3D, 2D comparison.
Yeah.
It's a good way to word it.
It makes it easy.
Yeah.
A little easy. Yeah. And so, in that you are shipping wall panels and floor panels and roof panels. And the advantage of doing that is, first, the shipping costs are a lot lower. Right? You're shipping on much smaller trucks. It's not oversized loads. So, the same trucks, as I said earlier, the same trucks that are bringing lumber and other building materials to the job site are the ones that are delivering these panels. You're able to get to more sites. So sometimes with modular, there are certain properties you can't get to because the road isn't wide enough or it's too windy.
Naturally, right? Yeah.
And so in this case, as long as you can get building materials to the job site, you can get
the panelized. Yeah. Wow.
Now, we're not including as much in those panels as you would in modular, but that's actually on purpose because we know that there are certain things that we feel builders, they really understand their market. They understand what the homeowners want, and they want to make those decisions on the fly. They want to decide between, this kind of countertop and that kind of countertop, this type of flooring and that kind of flooring. Sure. Sometimes they want to save that decision till much later in the process. So we've left that to them.
That's really interesting, right? Because I think as someone who isn't as familiar with this industry, when you think about, again, offsite, panelized, modular, the assumption is that it's almost build it and then place it and then you don't touch it. And it's finished product at that point. But what you're saying is it's totally accurate in the sense that builders would want to customize, or they have a better sense of the market than, maybe we do in a factory that's not, in said market or whatever the case may be. So it provides builders more opportunity to customize the finished product ultimately, right?
Exactly. And even the panels themselves are customized to each product. So,
right. Yes. Yeah.
So I mentioned earlier the process of getting to the manufactured panels, and essentially a builder would provide us with their blueprints.
Okay.
So it's their design, and all we're doing is taking their design and engineering it with high quality building science.
Sure.
Running that, manufacturing those panels to their spec through our automated manufacturing process that gives a very high level of precision. So, generally, Christian, I used to build homes, and we talk about, plus or minus 2 or 3 inches. It's all good.
Yeah.
And in truth, that's work.
Still okay.
But for us in a factory, we're building to 1/16 of an inch tall.
Oh my God.
So everything needs to be very precise because we want to make sure when those panels arrive on site that they just click together.
That's wild to think about.
Right away.
That is so cool. And so one of the things you just mentioned there, which I think we should revisit, is the pieces, if you will, are built to the builder's specs, right? It's to their designs, what they want the finished product to look like, not out of a dare I say, like, catalog of you can have this, this, or that. It's more you can have it any way you want. Am I on the right trail there?
Exactly.
Okay.
Yeah, so it's their design.
Yeah.
They tell us what level of energy performance they're looking to achieve.
Oh,
No matter what, they're going to get, very high level of performance, but they might want to achieve a certain certification, like zero energy ready or net zero homes, a certain HERS rating, which is a rating that's used to tell you how energy efficient your house is. So they tell us what they're looking to achieve, and we make sure that the
it's
finished
built to
product
that.
gets there.
Wow. What what are the ranges of, like, from a speccing standpoint, how energy efficient can you get? You said net zero there a second ago. What are those ranges? Do we have the ability to, is it a wide range, small range? Walk us through what you're able to do.
Yeah, so generally speaking, if someone says, I just want to meet code, usually we're still going to be about 50% better than code
Okay.
anyway. So that's
Okay.
kind of on the low end.
It's a great
And
sales point.
yeah, and that happens because of how tight the homes are built. Right? So it's not necessarily, in fact, for us, it's really never about how do we add more material.
Mm,
It's about how do we use the right material and build to a very high level of precision and airtightness so that we can let the insulation do its job and
right.
not need to, block airflow from coming in and out where it's not supposed to be. Or,
Right.
we're also really tightly controlling how moisture is managed through the house.
Mm,
And of course, I'm sure some of your other guests have talked about moisture management.
absolutely.
That's so critical both to the healthiness of the interior environment, the durability of the home, but it's also important to the energy efficiency.
Right. 100%.
Like in the winter, you don't want your AC spending all kinds of energy just trying to dehumidify the house.
Right.
How do you prevent that? Well, you manage that moisture.
Mhm. And you have more control over that. You, meaning the one precision assemblies, the offsite, the panelized construction, because it's happening in this controlled environment where you're not at the at Mother Nature's whim, right?
Yeah.
Ultimately, is what it comes down to.
Yeah, and I mean, someone can build an extremely high quality, high performing home the traditional way. It happens all the time.
Mhm.
The challenge is that it's very hard to do. And it's especially hard, on those days that it's super cold or super hot,
Yeah.
or maybe you're rushed because, the clock's ticking and you need to get out. And so from a builder's perspective, or let's say a GC's perspective,
Mhm.
making sure that no corners are cut, making sure that everything is done the right way, the exact same way every time can be very tricky on a chaotic job site.
Absolutely.
And of course, you have to take into consideration safety. And so,
Sure.
for us, it's actually very easy to achieve that high level of precision and performance because everything is set out in the factory in a very ergonomic way. There are standard operating procedures.
Oh, interesting.
This window is flashed exactly this way with exactly this material. The sealant is put here, this exact amount of sealant. We're measuring everything down to, as I said, the 16th of an inch
Right.
to make sure that it's consistently high quality, high performance,
Yep.
without adding more material, without adding cost.
Right. And so, which goes to my next part, or next kind of point, is it's incredibly efficient too,
Mhm.
right? You're not wasting materials, you're not wasting cost, because what you're doing is, yeah, pun intended, but it's down to a science,
Yeah.
right? Down to a building science almost. And being within a 16th of an inch, like you said, I mean, it's just incredibly efficient, the work that you guys are doing. And it's impressive as well, because I don't think as an industry have been properly introduced to it at this
Mhm.
point. I think there's an incredible opportunity for offsite, for open, for your team to get there,
Yeah,
get that
100%.
exposure. Yeah.
And your point about waste is a really important one. And the unfortunate thing is you go on a typical job site and you see a dumpster that's about the same size as the house
Yeah.
that's being built, right? And that dumpster is usually full of stuff.
It's overflowing.
And what that means is, of course, not great for the environment. It's a lot of wasted material, but it's also not great for the builder because that's just money that's being thrown out,
Yeah.
right? And it's not great for the homeowner because it's contributing to additional cost.
Mm.
Now, for us, you go into one of our, facilities that is building, can be, hundreds of homes, be hundreds of homes a month,
Wow.
and all you see is, little garbage cans,
Yeah.
labeled with, little pieces of wood this big and, little pieces of insulation that are this big. Everything that's cut off is reused somewhere else. And the way we're able to do that is actually we model that into these 3D digital models of every house.
Oh,
So we know
okay.
that if we're using this particular material here, but we need to cut off 2 feet of it to fit, then that 2 foot piece is used somewhere else, and that's put right into the 3D model.
Really?
Yeah.
Oh, another thing I had no idea about. That's so impressive. Keep going. I don't mean to interrupt. That is so cool.
Well, and you mentioned that it's good for people to know about this because
Yeah,
it's
absolutely.
it's often the case that we see hesitation on the part of builders to adopt offsite construction, and I think that one of the hesitations is around, well, I have a particular design, and it doesn't work for prefab. Now that's one of the reasons we used panelized construction is so that we're able to execute exactly the design that the builder wants. It's not there's no difference between the way that the house would look in it, using panels or built on site, and that aspect was very important because at the end of the day, what we're bringing is the building science and the quality. The design is up to the
Right.
homeowner and the builder. So, and another challenge that builders have faced in the past with using offsite construction is not knowing what to do with the modules or the panels when they arrive on site. So we decided to
Okay.
take care of that for the builder. So they don't need to learn a new skill set. How do I install panels? Don't worry about it. We got it.
Okay.
We're going to completely install it. And at the end of the day, we're going to do a blow a door test to prove to you and to us that the installation of those panels is perfectly tight. It's high quality,
Wow.
and as a builder, you're going to, leave at the beginning of the week and you'll come back at the end of the week and the house is going to be fully built and airtight. And now your crew comes in and makes it beautiful,
Right.
makes it their own with the, interior finishes and the appliances and whatnot.
It's so impressive. I want to start at almost back with the 3D and the waste, and then talk to me about how that gets planned for.
Mhm.
Is it does it come down to the cutting of the materials? Walk me through that and why we're able to, or why you're able to accommodate the waste in a reusable way as
Mhm.
opposed to throwing it in the big dumpster that's in, the front of the lot.
If you go on a traditional job site, pretty common thing, I used to be doing this all the time, is you'd see, you know, one or two people standing around kind of looking at something, maybe looking at the blueprint, scratching their head, maybe pulling things out because there was a mistake or some way that it was designed doesn't work. We do all of that virtually. So all of that, figuring it out happens in the virtual 3D model. So essentially we're building the house twice. We're building it as a 3D model, getting out all the kinks so that everything that happens on the job site where everything's expensive, where,
Mhm.
you have to be very concerned about safety, of course, where, it might be cold or hot or whatever it is, so
Mhm.
that can happen very quickly without needing to, be standing around scratching your head, figuring out.
That's one of the big, or was one of the big misconceptions. You've touched on a few more. Are there any others that you haven't mentioned up to this point that you think are that some people might be still hesitant
Mhm.
to either reach out, learn more, right, or even actually start the process of considering a panelized home?
So one piece relates to the topic that I mentioned about the building code. So there
Yes.
is a misconception that all kinds of offsite construction use a totally different building code. And what that could mean in some scenarios is maybe you're not eligible for the same mortgages or the same,
Mm,
home insurance or anything like that.
interesting.
Now, in the case of a lot of offsite, and that includes what we're doing, it complies exactly to the local building code. So there's absolutely no difference. Some of those inspections that would happen on site happen in the factory. We actually have more inspections. They just
Oh,
go faster because
sure, yeah.
the inspector is sitting outside the factory. So it's very easy to do. But the level of rigor around, was this executed to the local building code? Is the quality right? That is happening in multiple layers, just very efficiently and much faster. And in the factory.
Oh, wow.
And in terms of mortgages, 100% eligible for any mortgage. There's no difference
So no
from the
impact.
bank's perspective.
Okay.
I mean, maybe, the difference is the bank says, wow, this is going to use half the energy that another type
Another
of
one would
house
use,
is
yeah.
built. And so that puts more money in the pocket of the homeowner,
Yeah.
which makes them more eligible.
So it's a positive impact, a potential positive impact, right?
Yeah.
And a negative
Yeah.
impact.
And then from an insurance perspective, if I'm an insurance carrier and I'm looking at, a house that's built to, a very high performance and quality standard, one that's engineered. So actually all of our houses have a structural engineer that signs off on them.
Oh, okay.
I have a level of confidence that if, things that might normally cause damage actually won't damage this house.
Wow.
So I'm, maybe lower insurance premiums or easier access to, better insurance.
Better insurance coverage. So, yeah. So it's a potential net positive impact from going with the panelized. What are the other pieces that people maybe are missing when considering panelized and offsite construction?
If you're a builder, so one of the things you're struggling with is, you want to grow your business, but you can't find the labor to do it. Right? We know that it's a real challenge. And so if you're currently building 5, 10 homes a year, but you want to build 20, 30, 40 homes a year, it's really difficult to do it with the current labor pool. So what this allows you to do is, if you can build a house in half the time, first you can build more. And if that house is requiring less labor throughout the entire process, you have the ability to take the same team that you have, the same crews that you have, and deploy them on multiple houses at the same time. So it really allows you as a builder to scale your business. And of course, that results in more profitability.
Yeah.
And from a community perspective, it puts roofs over more people's heads.
Right. Which, and there's a housing shortage, I'd say. All right. And that's a great way to offset that. Offsite can offset that. Right?
Yeah. Well put.
That could be a new slogan.
Excellent.
We'll get there. The future of offsite construction 5-10 years from now compared to where it was 5-10 years ago, what changes do you see? What do you foresee the future looking like?
Already there's a lot of homes that are built with what I would consider offsite components. For example, trusses or roofs.
Okay.
Many, I don't know what the percentage is, but I wouldn't be surprised if it was 50% of houses are built with truss roofs. A truss is an offsite component. It's something that would normally need to be built stick by stick on the job site. It's being built in a factory and delivered to the job site and has, creates a very precise roof to complicated shapes. Framed wall panels. So just wall panel with just the framing and maybe the sheathing. That is extremely common in traditional construction all over North America.
Yeah.
So what I think that we'll start to see is just more enhancements of those components. So,
Sure.
If we can get all these benefits from having very precise, very fast production of wall panels with framing and sheathing and roof trusses, what happens when we add the insulation? What happens when we add the windows and, benefit from the economies of scale of buying thousands of windows a year?
Right.
What happens if we can very tightly control how those windows are flashed? If we can, install the membranes, the interior moisture, the vapor retarder, and the exterior weather barrier. Now, how much faster can we build, and how much can we still control the quality and the comfort of the house through that speed?
Dennis, you just talked about builders and why offsite is beneficial from their perspective. Excuse me. I have to wonder, it has to be beneficial for developers too, right? In this industry.
Yeah, I'm glad you asked that, because actually we're seeing a lot of benefits and a lot of interest from developers. And I think the reason for that is, imagine the economics of being a developer, an investor, building a community of, call it 200, 300 plus homes. So the traditional way of doing that is you'd build all 300 homes, and then you would just hope that they would sell quickly.
Yeah, right. You have to wait.
And you have a lot of cash tied up in that project. You're, probably paying financing over time, and that, adds up quite a bit, especially in this current context. So what what developers are moving more toward is essentially a model where they build a few model homes,
Sure.
and then they sell the designs based on those model homes to a future homeowner, and they have to tell the homeowner, great, come back in 12 months and your house will be there.
Yeah. I can picture that now, right? The development, right? You got the model homes, and now it's homeowner A, B, C. They want that, and now 12 months, right?
They have to wait.
Yeah.
Yeah,
Huh.
and that creates
also
some
cool.
risk.
Yeah.
Yeah, I mean, it creates, first, it's not awesome for the homeowner or the future homeowner, because what they're doing is looking at, okay, I can wait 12 months, but I kind of need a house now. And so maybe at that time they're starting to look at other options that are
Sure.
available to them, and we do see cancellations happening in a model like that because you're just giving too much time, and
Mhm.
things can happen. But what if instead the developer said, "Oh, you like this design, you walk through the model home, we can have that ready for you in a few months." About the same amount of time it would take to close on a pre-existing
Yeah.
home. So that, obviously has big economic and risk management benefits for the developer.
Absolutely.
But also it's just a better experience for the
Right.
homeowner.
For the homeowner, right? You're not waiting 12 months or longer to get the model home that you wanted. You're waiting a few months.
Yeah.
And if you don't want model home A, you can have model home B or whatever, or C,
Yeah.
or whatever the case may be.
And you have the same flexibility of saying, okay, I love this, but I want, different flooring and maybe different, sinks and different countertops. You still have that same flexibility.
Right. You're just picking the exterior. Thanks for tuning in to another episode of Building Science Digest. If you enjoyed this episode, make sure to like, subscribe, and share. You can also watch and listen anywhere you get your favorite podcasts.